Hey guys, welcome back to the channel and this new tutorial on Pytorch. So in previous video we learned about BatchNorm and how we can implement it manually. We did that as well. So in this video we will learn about what are the challenges with BatchNorm and how LayerNorm resolves them. Okay. So first let us look at the challenges. So first of all, the major challenge is with the batch size. If the batch size is 1, so it will fail because the variance would be 0, and also if the batch size is small, the mean and variance would be quite noisy because if the feature dimension is quite high in that sense. Okay. And also there is a big limitation if we are using batch norm with RNN. So for RNN training, we need a separate batch norm layer for each time step. And if the sequence length is quite big, in that case, we need to store a lot of statistics, and it will make the training too much memory consuming. So these are the two major limitations with batch norm. And there is another complex limitation which is with distributed training, but it is already implemented, so you don't need to worry about that. So I haven't added that in there. Okay. So if we look at the layer norm formulation, it is just slightly different than the batch norm. So if you look at here, so here we are computing mean with xij, where xij is nothing but one row or a column in a input matrix. Okay. So if you look at here, so xij, where j is being run from 1 to m. So m is the number of element in that particular row or column. So how it differs is mainly that in batch norm we simply take the feature or column in a input tensor, whereas in layer norm we take the whole feature of one single sample input to compute the mean and variance. That's how it differs. Okay. So it is independent to other samples, that's why it is called layer norm. Okay. So let us dive in and see like how it mainly differs. It is very slight variations that we need to do in the current implementation. So let us look at here. So this is our implementation of batch norm. Okay. Let us first change it to layer norm. So we can simply call it layer norm. Okay. And the second update is simply here, these two. So if you look at here, the mean and variance is computed on j, not I. In case of batch norm, we simply compute the mean and variance on I, okay, like in column, not rows. We will see with example like what we are doing. So what we will need to change is, we need to change this is equal to 1, this is equal to 1. Also you need to change the view or the shape of the mean so that it will be broadcastable, otherwise it will give us an error. Okay. So we will simply say view 1 cross, not 1, we need the n, which is nothing but the batch size, and we need 1. Okay. The same thing we need for this as well. So we need n and 1. So now first let us understand like what we meant by when we says x is equal to 0 or x is equal to 1. Okay. So let us first try to understand that. So let us print our x, which is a random tensor of 2 cross 3. So let us print. Now in case of batch norm, what we do is we take the mean of these elements. Okay. We sum these two and divided by 2, we sum these two and divided by 2, we sum these two and divided by 2. So we will have a mean of 3 different elements. Okay. Whereas in case of layer norm, what we do is we simply take mean of these 3 elements, that is all the elements of one input sample or one activation layer would be considered as would be used to compute the mean and variance and then normalizing it using the same. Okay. So, that is how it differs. So, in case of BatchNorm, we take the mean and variance in column dimension like in this dimension, whereas in LayerNorm we simply take the mean and variance in row dimension. Okay. That is why we said axis is equal to 1 in implementation. Okay. Okay, next let us implement layer norm here instead of batch norm. So, what we will do is we will simply say layer norm here, layer norm, and it won't take all these arguments. So, if you look at the implementation, it takes normalized shape and epsilon element wise affine is equal to true or false. By default it is true. So, we can say normalized shape is equal to nothing but the feature size. Okay, and that's all. We can uh, we can disable affine element voice affine, but it's okay to keep it true as well. So, now if we will run it, we get the output similar to what we are getting in case of our own implementation. Okay. So, let us run and see it. So, you see this is output from our implementation and this is output from Pytorch implementation, and they are exactly same. If you want to uh, have the uh, scaled and shifted norm to be similar to ours or similar to uh, Pytorch ones, we can simply use the same gamma and beta as it is used in Pytorch. So, in Pytorch the initial gamma is 1 and beta is 0. So, we use scaling factor 1 and the shift 0. Okay. So, now we will get this output as well similar to ours, similar to the one that we are getting from Pytorch. Okay. And it will simply train these gamma and beta which are initialized as 1 and 0 further with the data, and then later on it is used during inference as average. So, running average. So, it is similar concept when what we learned from the batch norm, it will be applied here as well. The only difference is like we compute the mean and variance differently, that is computed in batch norm. Okay. So, let us rerun and see it. Now, we should get this as well similar to this one. So, you see all three are now same. Now, I hope it is clear like what is the difference between batch norm and layer norm. In general, in the paper now from the team which was published for layer norm, they say that layer norm performs better than batch norm, and also it does not have this limitation of batch size as well as RNN. So, it is much better to train or use them in terms of optimal training setting as well. Okay. So, I hope that it is clear that what is layer norm and how we can use it. So, in this video we will stop here. In the next video we will start learning about how to implement the encoder layer, and then we will implement the decoder layer, and then we will make it encoder decoder architecture. Okay. So, thanks for watching. Bye for now. Take care. See you in the next.